Alright, so I want to do a few more examples with that antiderivative rule. We've only really studied the power rule for antiderivative, so it has to be in power rule form. If it looks like we have a multiplication or a division problem, we have to rewrite that before we can take the antiderivative. Now, alright, antiderivatives, alright, are the opposite of the derivative. It's asking us, what did we take the derivative of to make this thing, right? So if a derivative is multiply down and decrease the power, the antiderivative is completely opposite of that. So we raise the power and divide, right? So raise the power and divide. So what I want you to do, so I'm gonna pass out a hard copy to face-to-face students, online students. If you find the second line under the first page, 4.1 antiderivatives, the next line says antiderivative practice PDF. All right, so this is what I'm going to be working off of. You can open it up and just work on a separate piece of paper. Would be fine. Or just watch, because I have my screen presented, so you'll be able to see it off my screen as well. You're welcome. All right, so let's take the first one. All right. This symbol here, right? This means it's going to mean a couple different things in this class, all right? But all those things, concept-wise, are different, but they're related, all right, to really kind of look for the same thing at the end, right? So when we see this integral sign, this elongated S, that means find the antiderivative. Okay. It also means from our previous learning, what? When I put this on the paper, what did I have you find in section 4, 3, and 4?
Maybe I don't remember.
All right. Also, the area.
Oh.
Under the curve.
Never mind, I remember
Okay.
now.
So this is where we found those rectangles and trapezoids and things, right? When I put the integral symbol, that meant to find the area. All right. So these two things will overlap in the next couple of days. Finding the antiderivative goes hand in hand with finding the area under the curve. Okay. So let's find the antiderivative of 12x cubed. So what did we take the derivative of to make 12x cubed? Let's think globally, right? So I'm at a cubic function. What did I have to take the derivative of to make that cubic function? The fourth degree, right? So it's got to be a fourth degree polynomial. But the thing is, if I take the derivative of x to the fourth, I get 4x cubed. I need 12x cubed. All right, so put a 3 in the front. All right, and then we have our constant of integration. Maybe it'll show up in a second. All right. Now, thinking through that process, that was a little bit easier to think through, but it's not the easiest thing to do. All right, so we have a little procedure called upper power and divide. Now, if I apply that procedure exactly, you take 12x cubed, you raise the cube to a 4, and then divide by 4, and then you simplify 12 over 4 to be the 3 that we got here.
That makes sense. I didn't understand why you were doing that
Yes.
the other day.
So that helps with because we took the derivative of some, every function is a derivative of some other function. So whatever that function was, we had to multiply down and decrease power, right? So that whole multiplying down, we have to do the inverse of that, which will be to divide and get rid of, all right? All right, so let's take a look at number 2. All right, let's use the process. Right? What about that negative 20? What do we do with it? Do we need to worry ourselves about it right now? No. All right? We almost pretend it's not there. We don't really do anything with it. So it's just negative 20. Now, some people, I like to pull the negative 20 up to the front, right? But you don't have to. Let's just leave it like it is. It's a scalar multiple, right? So negative 20 and then x, right? We got to change the power. Up by 1. Becomes a 5, right? And then divide. Up a power, then divide. What do we divide by? The exponent, 5, yes. Right. Now, if this was on a multiple choice test, you're gonna have to simplify that to be negative 4x to the 5th plus c. You can always check to see if you got it right by taking the derivative of your final answer. 5 times negative 4 will be negative 20, decrease power, so multiply down, decrease power, same. All right? All right, what about 10x? What's it become?
Squared.
What becomes squared?
Exponent.
The exponent for the x. All right, and then what goes on the bottom?
2.
So my final answer is
5x squared.
5x squared plus c. Perfect.
Huh? Yeah, I was not even understanding this the other day. I wasn't understanding the basics.
It's crazy the difference in being,
Now I get it.
yeah, in the building and at home, right? All right, so take a second and try to do 4, 5, and 6.
I think my eyes were hurting too. I've been on the computer all day. Pooping.
And I think what you'll notice is the more of these you do, the more comfortable you become, the better and faster you become at them. All right, so I wanted to make sure that today, because this is the first, really the first thing for the whole, next semester. We did do a little bit of the area under the curve, but I haven't yet matched that idea of the area under the curve with the antiderivative. So from now on, we're going to have to be able to use that antiderivative. I want to make sure we're all in a good situation to move past this. I think we will be today.
Is it the same concept if you have like 2?
Yeah, it is. You just do the individual parts. Whenever you're separated with a plus or a minus, you just do each part separately with the plus or a minus between. You cannot do that with multiplication and division. Same as derivatives. When we have the derivatives,
and divide.
right, right. So when derivatives, when we had a plus between them, we just took the derivative of each of the individual parts and then left the pluses and minuses.
Yeah.
When we got to multiplication with derivatives, we had to use product rule. We had to use a completely different approach. When we had fractions, we either had to rewrite it or use quotient rule. So same thing's gonna happen with these. If it's multiplication and division, you're going to have to do something to it first. Until we learn some other rules.
I don't remember if we learned that yet. Like for this stuff.
No, we have not.
Okay.
The only thing we've done is the power rule of the power and divide. Alright. So number 4, we go up power and divide, so negative 6x to the second divided by 2. Right, and that's going to simplify to negative 3x squared plus c. Yeah? Alright? What does this first part become? 15x to the 4th becomes?
15x to the 5th. And divide by 5.
15x to the 5th divided by 5 plus the 10x becomes?
10x squared. 2.
right, which we actually already did earlier, right, plus c. And then simplify, 3x plus,
squared
yep,
plus c.
perfect. Alright, negative 30x to the upper power of 6 divided by 6 plus 12x upper power of 3 divided by 3 plus c. Right. Final answer, negative 5x to the 6 plus 4x cubed plus c. Alright, any questions about this? Alright, so rather than continuing to do these other ones, we'll.
Oh, if there's just like a 1 there,
Oh,
is the
okay.
exponent
No, that's
still?
good. I'm
Okay.
glad you pointed that out. Because really, when it's just a number by itself, right, so on number 7, that's really 1x to the 0,
Okay.
alright? Now, I don't typically write this a lot, right? I think about it like this, right? I've got a constant here, a plus 1 is a constant.
Mm-hmm.
What did I have to take the derivative of to make a constant? A linear.
Mm-hmm.
So I know now that my answer to the antiderivative must have an x to the first power.
Okay.
But when we see it like this, we can use our rule upper power divide, because we're at 0, we upper power to 1. Alright, so your answer for this one's gonna be negative 6x to the 6 over 6 plus x plus c, or negative 1x to the 6 plus x plus c. We can check. The derivative of negative 1x to the 6 is negative 6x to the 5th. Boom. The derivative of x is 1. There it is. The derivative of a constant is 0. Very good. Glad you pointed that out. All right. Now next, this next section, 9 through maybe 14, we have a multiplication in there. Okay. And when we have multiplication, we can't use a product rule. We don't have a product rule for antiderivative. So our only option right now is to rewrite it and try to do power rule. All right. Now I forgot when I was making this worksheet earlier. I forgot to do anyone that had like a second degree here, where you would have to just multiply it out by itself. But it works very simple, right? So first thing we have to do is rewrite as the integral of 3 times 2, 6, x to the 2 and 3 gives me a 5x's, or x to the 5th, and then 3 times 3 is going to be a 9, x to the 2nd. Now we made the problems look like the previous problem. Right? Once we've done that, we've had practice with those. Now we're ready to take the antiderivative, upper power and divide. So this will be x to the 6 plus 3x cubed plus c. Now you may have to have an intermediate step at this point, right? But you'll get better. You'll get really fast at it. You say, oh, okay. The derivative of 3x cubed is 9x squared. All right. All right. Why don't y'all try 10 real fast? Alright, people online, if y'all have a question, y'all can always unmute or try to put it in the chat. Alright, so I got 2x to the 4th minus 2x squared. Let's see. Okay. Alright. Do we need to do any more of this? Feeling pretty good? Get more comfortable? Settling in a little bit? Alright. So, let's add in the,
yeah, we can go back to the last
go back to the last ones, yes?
one. No, I'm joking.
I know you are. Alright, so let's throw in the negative exponents, okay? Now, the only difference between the negative exponent and the positive exponent is don't get confused on which way the number line's going, right? Anytime we increase a power, when you increase something, you move to the right on the number line. So that's how I think about this, right? So negative 3, all right, we know that that's going to be negative 3x, right? This is a constant, so the antiderivative must be a linear. Because you take the derivative of linear, make it constant, all right? Minus 8x to the, all right, so we're at negative 5 on the number line. We need to increase the power, so we move to the right one place, puts us at negative 4. All right, and then we divide by that power. So negative 3x, negative over negative is going to be a positive 2. X to the negative 4 goes to the bottom as a positive 4 plus c. So that would be your most likely answer choice on a multiple choice test. If this is for response on the AP exam or my exam, you can leave this first answer. You don't have to simplify, right? I think a lot of our confusion over the past, on Tuesday was maybe due to the algebra stuff that I was doing, right? Right, and that's always been the case in our class, right? The calculus concepts we get pretty quickly, but the algebra that we need to do the calculus concepts sometimes hangs us up a little bit, okay? But we'll get really good at that too. All right, so what is the antiderivative of 4? 4x, so minus 2x to the what power? Negative 1 divided by? All right. Negative exponents do not like being where they're at, all right? X to the negative 1 does not like being in the top. It's going to go to the bottom, all right? So 4x, all right? Then we have negative over negative, that's going to be a positive. We have a fraction, right? 2 over 1 is going to become a 2. X to the negative 1 does not like being where it's at, so it goes to the bottom. Remember in the front of your notebook, you have the derivative of 1 over x is negative 1 over x squared. Hopefully, somewhere. All right. If you had rewritten this negative exponent to start with, you would see 4 minus, I'm going to bring this 2 out to the front, and I'm going to put 1 over x squared here. Antiderivative of 4 is 4x, because the derivative of 4x is 4. All right, here's my 2. What do you take the derivative of to make 1 over x squared? Well, 1 over x, but it's a negative here, so it's got to be a positive. Or 2 negatives and then get a positive. All right, any questions about the negative exponent?
I think I'm still confused about the 2 over x, so can you explain it one more time?
Okay. So the first thing I did was to change this. Right. The first thing I looked at was this negative 2 over negative 1. And that's going to become a positive 2. Okay. And then I took x to the negative 1 is on the top of the fraction. It does not like being there. So I moved it to the bottom of the fraction and really made it a positive 1.
That makes sense.
Okay. All right, why don't y'all get 15 to try? All right, find me the antiderivative of negative 6x plus 2x to the negative 3. In other words, what do we take the derivative of to make that? All right, then your final answer, make sure that you have all positive exponents.
to do with, I think I don't remember how to do algebra. Like this stuff right here, how I know that this eventually has to go down here.
Perfect. And then you just divide these other two.
You divide these?
Yeah, because, yeah. So if that was all by themselves, you would just think it as 2 over 4, so negative 1.
Okay, thank you.
You're welcome. So on Tuesday, I was doing a lot of the key change flips, because I had some fractional exponents. And then when me and the other teacher were talking about it, we realized that a lot of people we jumped too fast from one type of question to the next type of question, and y'all didn't get enough practice within each type of question. So
also, I didn't catch a lot of it because my Wi-Fi was being so stupid. It kept cutting out.
Yeah, with the whole world on Wi-Fi right now, it's sorry. All right, so we go up power and divide. So 6x to the second over 2 plus 2x to the negative 2 over negative 2. So yeah, check that too. I didn't catch that.
Yeah, I did that.
All right, so we move to the right on the number line. All right, so we get a negative 3x squared. 2 divided by negative 2 is going to be a negative 1. X to the negative 2 does not like being at the top, so I'm going to put it at the bottom and change the exponent to positive. All right. Any questions? All right. Now, let's look at number 17. All right. So number 17, we have this rational right here, but we don't have any kind of quotient rules. We need to rewrite that so that we can use the power rule, right? So the previous problems that we just did had negative exponents. So what I want to do is I want to rewrite this particular problem where 16 over x to the 5th has a negative exponent before I do the antiderivative. All right, so we're going to rewrite negative 18x to the 5th minus 16x to the negative 5th. Now it looks like the previous problems that we practiced, right? So if we can always take something that's new looking and make it look like something that we've had experience with, we're much more likely to get it right. All right, so I don't need the integral sign anymore because I'm going to take the antiderivative. So negative 18 x to the 6 over 6 minus 16 x to the negative 4 over negative 4. Let's see. All right, so negative 18 over 6 is going to become negative 3. X to the 6 is perfectly fine where it's at. Negative 16 over negative 4 is going to be a positive 4. This x to the negative 4 does not like being where it's at, so we've got to move it and change the exponent. Right, and that would be your multiple choice answer. Okay. All right. Do you want me to do one more of this first? Before we move on, you're all okay?
I'm good.
Everyone okay about it now? All right. One line. All right. Now, so let's look down to number 23. All right. Let's see another question, kind of similar to this on the quiz, I believe. So we have this quotient, but we don't have a quotient rule for antiderivatives. So what do? We have to rewrite it, right? That's our only option, is to rewrite and then try. Now, we got a couple different ways we rewrite. I prefer the Hart method, right? But I know some of you don't particularly like the Hart method, but, right? I'm gonna do that first, and then I'm gonna do it another way in a second, all right? So if I look at this first circle pair, 5x cubed over x to the fifth, that's gonna reduce to 5 over x squared. Right, I have 3x, x times x times x on the top, x times x times x times x times x on the bottom. All right, so the bottom has more, it gets all the leftovers. All right, minus 16 over x to the fifth. I'm gonna, well, let's just write it right. 16 over x to the fifth. Nothing cancels yet. All right. All right, so we're rewriting. All right, we're going to continue to rewrite this with a negative exponent and make it look like the last 7 questions we just did. All right, from there, 5x to the upper power negative 1 over negative 1 minus 16x to the upper power goes to negative 4 divided by negative 4 plus c.
So you wouldn't require us to like go beyond that?
If it's a multiple choice question, yeah, you're gonna need to rewrite that. Where your final answer is gonna be negative 5 over x, and then plus 4 over x to the 4th, let's see, something like that. Now, if you don't particularly like that Hart problem, Hart method, right, what a lot of students do like to do then is to rewrite x to the fifth with a negative exponent. Anybody good so far? Okay. Right, so you could write it like this, 5x to the 3 minus 16 times x to the negative 5 power. Okay, and then distribute out, right? Because a lot of times we're more comfortable with multiplying with the same base, you add the exponents. Right, so this becomes the integral of 5x to the negative 2 minus 16x to the negative 5. All right, and then it looks exactly the same as the other one did, okay? All right. Questions about that? All right. So I think I'm gonna, let's do, I'm gonna let you do number 25, and that'll be the last thing we do before lunch. After lunch, I'm gonna talk about the rational exponents, and then the radicals that can be rewritten as a rational exponent, and then I'll jump back into the original lesson. Right. But I definitely think the 45 minutes that we're gonna spend on this is gonna save us hours down the line.